So we'll be solving differential equations. And so just a couple of reminders here before we get into it too far. So back in your chapter 4, so way back in chapter 4, we already have done this style. And so our first step, remember, is that we always want to separate our variables. And so what we want is having our y and our dy terms on one side, and then have that equal to our x and our dx terms on the other. And then once we have that separation of variables, then we would integrate both sides. And so what's going to be different is in our chapter 5 is we'll have more integration techniques that we've learned and patterns that we've worked with. And so that will be an added struggle because of multiple integration components that we have to pay attention to. And then finally, if it's asking, we will need to find the value of C, and that would be if we were given initial conditions, right? So given some sort of values ahead of time. Okay. All right, so then a couple of review ideas here as well. This is back in our algebra reviews. So this would have been probably in like math 8 initially when you were doing linear, and then again in math 3. So if you are hearing the words y is proportional to x, then this is the equation that you would have. So y is proportional to x, meaning a multiple of x, and that's what that means. So in general, we would write y is equal to kx, where k is just your scalar. In math 8, it probably would have been m for slope, so m for slope. And then the other vocab conversion is if it's inversely proportional to x. So inversely meaning y is equal to k times 1 over x, or just k divided by x. So same thing there. So those are the two things that we need to make sure that we know that kind of language. So when we go through and we start solving. So for our exponential growth and decay model, so y is a differentiable function of x, and y has to be greater than 0, and that would just be because of that exponential component. The rate of change of y with respect to x, so remember whenever you see that word rate, you're thinking like d over something, right? D, and then in this case, rate of change of y, so the rate of change of y would be dy, and then the with respect to x, meaning dx, right? And then if that is proportional to y, oh, and I just realized I have wrong variables here. So we'll, so say this is t with respect to t. So a little typo there. So the rate of change of y with respect to t, so that would be the dy over dt. And then the is proportional to y. So that's, this kind of piece right here. So proportional meaning some sort of scalar, so k in this case, and then proportional to y, so times y. And so what we want to show is that y equals c e to the kt is the solution to this differential equation. So we're going to follow the steps just like we had before in chapter 4. So our step 1 would be just to separate our variables, right? So our equation that we're working with, so dy over dt, and then that's equal to k times y. So our step 1, right, is to separate the variables. So I am going to multiply by dt because we want to clear those fractions. And so that would just equal 1 over here. And then we would have dy is equal to k times y times dt. And so if I'm still looking, I still am not fully separated at this point, right? So I have to get the y over to the other side. So then now I'm going to go ahead and divide both sides by y. So y divided by y would just be 1. And you can multiply, or divide by that ky as well. But we're going to go ahead and just do just the variables. Okay, so if the constants are already on the right side, just leave them over there. And so then what we would have is we would have 1 over y with respect to y, and then we would have k being with respect to t. And remember, k is a constant, right? K is a constant. So my variables are now separated because k is not a variable. And then now for step 2, we want to integrate both sides. So we're going to integrate both sides. And so the integral of 1 over y, so that's just the same as y to the negative 1. And k, again, is just a scalar, so I'm just going to move that to the front. And so I'm going to integrate 1 with respect to t. So y to the negative 1, I can't do power rule, so that would just be the natural log of the absolute value of y. And then that's equal to k. And then the integral of 1 with respect to t would be t. And then I'm just going to have 1 plus c. So remember, there is a plus c for both sides, but when we like combine them together, so it's like c1, c2, that just gives us that value of c. So we're still not done though, right? Because I need to show that this is the solution to that. And so now we have to kind of review our ideas. So now I need to get y isolated. So I need to know, okay, well, what's the inverse of natural log? And that would be exponentiating, right? So then I need to raise both of these to the power of e in order to isolate the y, right? So I'm trying to get the natural log undone. So I'm going to make both of these values to the power of e. And so now keep in mind that the whole thing has to be exponentiated. So the kt plus c, all of that has to go into the power. So e and natural log just cancel each other out. And so I would have the absolute value of y is equal to e, and then all of that is up in the power. So a couple of things here, they tell us that y is greater than 0, so that means I don't need the absolute value. And then the second component is it still doesn't look like what I'm trying to get, right? It still doesn't quite look like this. So now I have to like figure out, all right, what next, right? And so this is going to be a technique that we're going to use. So we need to make sure we understand this. So just kind of like just off to the side here is I know that when I have a common base, so if I have x to the a and x to the b and I'm multiplying, I would add those powers, right? Like that's what I know. So the property, so we're going to use this property, but we're going to use it going the reverse way. So if I have a sum or even a difference, but I'm going to use the sum version, I can split that apart and say that that's the same as x to the a times x to the b. So that's just using that law of exponents that we know. We're just going backwards. So up here, I have this kt plus c, which is like the a plus b, and I'm going to split it up. So e will become the base for both kt and c, but it will be a product, right? And then again, that's just we're using that law of exponents in a reverse way. So this would be e to the kt and then times e to the c. And then e to the c is just another constant, right? Because e is a number value, c is a number value. So that is just a whole nother constant. And so typically when we do that, we would just, oops, let me spell it. That's a T, not a D. Okay. So then this would be y is equal to e to the kt, and then that's just another constant. And then I'm going to use a capital C, but I could do like C1, C2. And so then that, if I move it to the front, is what we were trying to show. Okay, so a lot of that skill that we just kind of went through is going to be used here and there. All right, so let's go ahead and take a look at the first example. So for example 1, it's asking us to write and solve a differential equation for y if the rate of change of y with respect to x is 4 minus y. Okay, so the rate of change, so whenever I see rate of change, I need to be thinking like the derivative component. So we want the rate of change of y and then with respect to x. So all of that is, so the rate of change of y with respect to x. So that would be dy over dx is, so is meaning equals to 4, or is 4 minus y. Okay, so no proportional, right? That's just what it is. Okay, so then my first step, you know what, I think I'm going to need some extra room. So let me erase this and just scoot it over so I give myself plenty of room here. Okay, so my first step again, so I'm going to clear my fraction. So I'm going to multiply everything by dx, so the left side and the right side. And feel free to do like, more than one step at a time. Like that will be fine. Like don't think you need to do, one thing. Okay, so then I will be left with just dy and then equal to 4 minus y, keeping in mind that that's grouped. And so then now when I want to isolate, I'm still not done, right? So because I have a term of y over here with the dx. So I cannot just add y over because it's being multiplied by dx. And then certainly distributing is not going to help me either. So I have to keep that 4 minus y grouped, and I need to divide both sides by 4 minus y. So then I'm going to go ahead and rewrite at the same time. So 4 minus y in the denominator, I'm going to go ahead and make that up into the numerator as a -1 power. And then this is just dx, but in particular it's 1 dx, right? So then I'm going to, once I get my variables separated, which I do, right? Because I have my y term with my dy, and then I don't have an x term, so that would just be that. So this side's easy to integrate, but this side a little trickier, right? Not terribly so, but just a little bit. And so it's going to be a u to u. So I would let u equal 4 minus y. And then that derivative would be -1 dy, but I don't have a -1. I just have a dy. So that means I need to divide both sides by -1. And then I will do that substitution up here. So then I will replace 4 minus y with u, and then dy will replace with du over -1, but I'm just going to pull that negative out. And then equal to, and then the integral of 1 with respect to x would just be x plus c. And then over here, I can't do power rule, otherwise I'd be dividing by 0. So that means it's going to be natural log. So that'll be negative natural log of the absolute value of u, but I'm going to go ahead and substitute in the u, which was 4 minus y, and then equal to x plus c. Okay, so again, we do need to solve for y, so we are not done. We are not done. We need to keep going. Okay, so the first thing I'm going to do is, so I'm trying to isolate y, so I'm going to divide both sides by -1. And so that will just leave me with natural log of 4 minus y. And then x divided by -1 is -x. And then c divided by -1 is -c, right? Or I just know it's another constant. So if I left it as a plus, that's okay as well. Okay, so but technically then this would be like a c1 and a c2 because now they would actually be different, or they would be opposite values, but they would be different. Okay. All right, and then one more here. So now for the natural log, so I would exponentiate both sides. So I'm going to be a little lazy with that and keep that grouped though. Remember, that's all one thing. So this would reduce to just the absolute value of 4 minus y. And then I'm going to use that same technique that I did previously where I'm using that kind of laws of exponents. So like this part up here. So I'm going to be copying that same idea. So then this would be e to the -x, and then times e to the c. And again, I'm just going to write them as constants, even though they're all different constants from each other. So again, just to double check, so if we have same base, we add our powers, and I'm just using that rule backwards. Okay. So then I have the absolute value of 4 minus y. And then e to the c is just another constant, so I'm going to use a capital C to represent it being something different than it has been all the way through. So at this point, I can kind of leave this as, leave that alone if I wanted to, or I can go ahead and keep solving, and sometimes you will have to because it'll be very specific. Oh wait, it does say that. For y. Okay, so I do have to keep solving. Okay, so for the absolute value, that just means there's a positive and a negative version of c. And so then now I'm going to subtract 4 to both sides. So I'm going to put it in front though. So subtracting 4. And then dividing by -1. So then I would get y is equal to, that would be positive 4. And then I have plus or minus divided by -1, so plus or minus c e to the -x. And really that plus or minus isn't even that essential just because of the fact that if c is positive or negative, like that's your constant, right? So it really would kind of incorporate and be dependent upon some sort of initial condition, and that would help you decide, okay, well, which is the correct form, and that would be given somehow with an initial condition if we needed to keep solving. Okay? All right, so let's go ahead and take a look at example 2. So for this one here, so they want us to, essentially do the same thing. I guess I should have more directions on this, I just realized, but do the same thing. So the rate of change of n is proportional to n when t is equal to 0, n is equal to 250, and then also when t is equal to 1, n is equal to 400. So all of this is giving us, enough information to figure out, okay, we've got a lot of solving we have to do. Okay, so we know that the rate of change of n is proportional to n. So the rate of change of n, now it doesn't say with respect to anything, but it's implied because of that whole t equals 0, t equals 1. So there's an implied rate of change of n with respect to t. And I keep trying to steal space. So let me grab that back. Okay, so rate of change of n. And again, it's implied with respect to t. And then is, meaning equals. And then proportional to n. So this is that review off of the very beginning. So proportional meaning a multiple of n. So we have to, even though the directions don't say, my intention was to solve for n and also filling in all the constants that we will be creating with the given information. Okay, so first things first is we're going to multiply that dt over to the other side and then divide by n. So that is just to separate my variables, very much like that very first problem that we did. And then from there, we're going to integrate both sides. So integrate both sides. So then we are really integrating into the -1. And then k is a constant. So we're integrating 1 with respect to t. So this would be a natural log, right? Because if I try to do power rule, I would end up with dividing by 0. And then integration of 1 with respect to t would just be t and then plus c. All right, so I need to isolate n. So to get rid of that natural log, I'm going to exponentiate both sides, keeping in mind that this is all grouped together. And so from here, e to the natural log, so then that would just be absolute value of n. And then I'm going to use that law of exponents backwards. So this will be e to the kt and then times e to the c, right? So I just split this up. So base of e. And then when you're multiplying, you add your powers. And so I'm just undoing that rule. And then e is a value, like 2.7. C is also a value, like 12. We don't know what it is. So this is just a whole nother constant. The other thing, too, is we can see that n is positive, right, what we're working with. So we don't need those absolute values because n is positive. So then what now I'm left with is n is equal to c e to the kt. So if all I had to do was solve for that equation of n, ta-da, we're finished. But now we're given information to help us find what the values of c and k are. And so we're going to have to substitute in twice so that we can use both of these pieces of information. So I'm going to start with this one. So when t will be replaced with 0 and n will be replaced with 250. So that would give me 250 and then c, e, and then k times 0. And then this would be 0 and e to the 0 is 1. So then I know c is 250. Okay, so there's c. So I know that one. So now I'm left to finding k. So now I'm going to just start that same process over again. So I have n is equal to c, which is 250, and then e to the kt. But now I'm going to use this bit of information to help me solve for k. So now I'm going to replace n with the 400 and t with the 1. Okay, so then now I'll just solve for k. So I'm going to divide both sides by 250. So I would have e to the k. Let me do a little reducing. So I'll divide out the 10, and then let's see, I can divide out 5, so 8/5. Okay, and so one more step because I have to still isolate for k. So just like I exponentiate, right, use e to inverse natural log, I want to use natural log to inverse e. So then now I'm going to go ahead and take the natural log of both sides. And so this would be k times ln of e, which is just 1. So that would be 1 times k, which is k. So then now I know the value of k as well. And if you have that as a decimal, that's fine, but not necessary. So then my actual answer, though, has to be that equation with those two numbers substituted in. So I'm going to use this right here, but I'm going to replace k and c with the values I just solved for. So this would be n is equal to c, which was 250, and then e to the k, so k was the natural log of 8/5, and then times t. And I think I'm going to group that so it is obvious that that's what I got. Okay, so there is example 2. All right, so let's go ahead and do another one here. So for example 3, we want to find the general solution. So that means we won't have to solve for c, so that's exciting, of this differential equation. So again, we're going to just kind of do the same thing we have been doing. So I'm going to multiply the dx over to the other side. That'll be my first step. And I'm going to just do that kind of automatically. And then it's still not separated, like that wasn't enough. So I have to get the 3y squared over. So then now I'm going to multiply both sides by 3y squared. So now that everything is separated, I can go ahead and solve, right? So I can integrate. So let's go ahead and do that. So we're going to integrate both sides. So for the left side, I'm going to just do power rule. So I'm going to add 1 to the power and then divide by the new power. And then just reserve the plus c for the other side. So I'm going to do this over here as well. So add 1 to the power and divide. And then 2 will be 2x and then plus c. And then let's go ahead and isolate y. So, well, 3 divided by 3 is just 1. So that's 1. So then I'm going to cube root both sides to get y by itself. So then this would be the cube root of, and then all of this would be underneath, including that plus c. And that would be my answer. So that one was a little bit easier. Okay. All right. And then let's go ahead and take a look at our last one here. So this one, instead of a general solution, we do have to find the particular solution. That means we have to solve for c. That's what that's saying when they say the particular solution. And so they're saying that y of 1 is equal to 2. So that means that your x value is 1, because this is like f of x or y of x. And then this is my y value. So y of 1, so that means x is equal to 1, and then equals 2, so that means y is equal to 2. So this one we have to do a little bit more work. So I'm going to go ahead and start with just adding the natural log over to the other side. And so that is an L. I know it looks like an I, but it is an L. And then y prime is the same as dy over dx. So I'm going to go ahead and do that as well. All right, so all I did was add the natural log of x squared over, and then y prime is the same as dy dx. So then I'm going to go ahead and multiply both sides by dx, but the other thing I'm going to do is, because that's a power, I'm going to pull that down just to make the integral a little bit easier. So then I have 2x dy, and then I'm pulling that 2 down as a coefficient and multiplying the dx over. So I have things kind of scattered. So I need to get the x over to the other side. So let's do that. And I'm going to go ahead and actually take the 2 with it this time. I know I don't always do that. And the only reason I'm doing that, because I know that it'll cancel here now. So then this will be left with just 1 dy. And then over here, 2 divided by 2 is 1. And then I'll have the natural log of x times 1 over x dx. Or if you left it as ln of x over x, that's fine as well. Okay, so then now I need to integrate both sides. So this integral's easy, right? That's just y. So this one, not so much. So let me go ahead and pull that up. So I have natural log of x times x to the negative 1 dx. So this is a little bit tricky, right? Because I have to figure out, okay, so what is going to be my u? Because I have nothing grouped, right? Like, well, x is not a group, but it's just to a power of negative 1. So this is kind of a trickier integration. So in my mind, when I look at this, my choices for u that I could use, and I'll do that over here off to the side. So for this one right here. So when I look at this, this is definitely not a pattern we've been taught. So what I could think of is, okay, so does that mean u is natural log of x, or is u x to the negative 1, right? Like I have to figure out what's the correct format of u. And please don't let u equal x, because that is just changing variables, which is not going to be helpful. Okay, so don't ever let that be a choice. So I honestly don't know, like what should be my correct u. So I don't know that. So I'm going to go ahead and take the derivative. So the derivative of the natural log of x is 1 over x dx. And so that aligns perfectly, right? So u is ln of x, and then both of these grouped together is the same thing as my du. So this seems to be the correct choice. I'm still going to go ahead and work this one out so you can see why it would not be the correct choice. So this derivative over here, if I do power rule, would be negative 1 x to the negative 2 dx. And that is not lined up perfectly. So this is not the correct choice. Okay? All right, so let's go ahead and work this out. So again, my left side, I have y equals, and then I'm going to do my substitution. And I'm going to use this over here for my substitution. So ln of x here is going to be replaced with u, and x to the negative 1 dx is the same thing as 1 over x dx, which will be replaced with du. And then now let's go ahead and integrate that. So that's to a power of 1. So power rule, I'm going to add 1 to the power and divide, and then plus c. And so then that would just be y equals 1/2. And then u was the natural log of x, and then that's quantity squared, so I cannot pull the 2 down because it's not just x being squared, it's that whole natural log of x. And I wish I was done, but I'm not. I still have one more step. Okay, that sounded terrible, sorry. So I still have one more step. Let me sound perkier than that instead of dreading. So I would replace x with 1 and y with 2. So that would be 2 and then 1/2. And then replace x with 1, and then keep going. So the natural log of 1 is 0. If you didn't know that, you should know that. So this would just all be 0 plus c. So then that means c is equal to 2. And then now for the final step is go ahead and you're going to take that equation that you solved for here, and you're going to replace c with 2, and then that will be my answer. And then again, one more time, I cannot pull this power of 2 down to the front because it's all of this being squared, not just the x. Okay, so that is